Hello students, welcome back to the second lecture. In this lecture, we're going to discuss Chapter 2, Describing Data, Frequency Tables, Frequency Distributions, and Graphic Presentation. Let's start. So the learning objectives of this lecture are 1. Summarize qualitative variables with frequency and relative frequency tables. Display a frequency table using a bar or a pie chart. Summarize quantitative variables with frequency and relative frequency distributions. And fourth, display a frequency distribution using a histogram or a frequency polygon. Let's start with the first one, constructing a frequency table. So, frequency table is a grouping of qualitative data into mutually exclusive and collectively exhaustive classes, showing the number of observations in each class. Again, this is applicable to a qualitative data. And mutually exclusive means that the data fit in just one class. And then collectively exhaustive means that there is a class for each value. Okay. So I'll give you an example in this table 2.1. It's the frequency table for vehicles sold last month at Applewood Auto Group by location. So there are 4 locations that represents the vehicles sold. So it's the Kane, Olean, Sheffield, and Tionesta. And so it is mutually exclusive, which means that the vehicles sold must be in Kane, in Olean, in Sheffield, or in Tionesta. Okay. And it also has to be collectively exhaustive, means that for all the 180 number of cars sold, they have to fit in one of the 4 classes or in one of those 4 locations. So they have to be collectively exhaustive. If it's not collectively exhaustive, then it could be that there is at least one vehicle sold not in this location. Okay, so in this frequency table, it's very simple to see that there are 180 cars sold, and then from this table we can see that the number of sold, the highest number of sold is in Kane, and that the lowest number of cars sold is in Olean. So it's very simple. So to construct a frequency table, you just have to first sort the data into classes. So classes in this case is the location, and then count the number of the number in each class and report as the class frequency. Again, this is relatively manual in the sense that you have to do it one by one. However, with technology nowadays, as simple as Microsoft Excel, and then as complex as something that you need to code, such as Python or R or SPSS for that matter, then it's going to be more straightforward, and then the computer and the technology can do the heavy lifting. So that's something that you can take advantage of using these softwares and this technology to help you to make this simple graphical or table presentations. Now, another thing that we can do is actually to convert them into relative frequency. This is again going to be relatively useful for business decision makers in terms of knowing which location actually has the best performance in terms of vehicles sold. So instead of just counting the number of cars within each location, what we can do is that we can calculate the relative frequency of the number of vehicles sold within a location to the total number of cars sold, which in this case is 180. And so in this particular case, we're going to show the fraction of total numbers of observation in each class. So basically here, 0.289 can be calculated by dividing 52 with the total number of cars sold. Okay, and then we can also get the share of vehicles sold in Tionesta of 0.239 by dividing the total number of cars sold in Tionesta by the total number of cars sold, which is 180. Relatively straightforward. Now, again, with this relative frequency data, now I have, for example, as an owner of the Applewood Auto Group, now I know that the highest share of vehicles sold is actually in Kane, and then the lowest share of vehicles sold is actually in Olean. Okay, so this particular relative frequency provides you with a better and insightful information about how this vehicles sold are actually distributed across location instead of just the numbers. Okay. Now, another way of presenting a qualitative data is actually through a bar chart. So a bar chart is a graph that shows qualitative classes on the horizontal axis and the class frequencies on the vertical axis. So here is the qualitative classes. Okay, you have the location from Kane to Tionesta, and then you have what's called the class frequencies on the vertical axis. So the class frequencies are proportional to the heights of the bars. So as we know from the previous frequency table, there were 52 cars sold in Kane, and so there's about 52 cars sold here. And then we know that there were 40 cars sold in Olean. Now, again, you can actually make a more informative graph than the one that you have here in the slide. For example, what you can do is that instead of just reporting the number of vehicles sold, what you can do is that you can also report their relative frequency in the y-axis instead of the number of vehicles sold. That's one thing that you can do. Again, 50 doesn't really reflect the distribution or the share of vehicles sold within a particular automobile dealer. But then if you know the relative frequency, you have that better sense. Oh, the highest sale is actually in Kane, and then the lowest sale is actually in Olean. Another way that you can actually make this graph more intuitive and then more easy to understand is actually to sort the bar based on the observations. Okay, so for example, what we can do is that we can actually start with Kane, Sheffield, Tionesta, then Olean, and then we get a descending order of graph. Another way to make things more straightforward and more intuitive is to actually provide a label in each graph on the number of vehicles sold. In this case, this is 52, this is 40, and then we can also include the number of vehicles sold in Tionesta and Sheffield as the label on top of the bar. Well, again, this is just a simple detail to make your graph more informative and easy to understand, especially for executives or business decision makers with only 5 minutes to spare between meetings. Another way of presenting this, qualitative data is through pie chart. So this is a chart that shows the proportion or percentage that each class represents of the total number of frequencies. So in this particular case, you can use a pie chart when you wish to compare relative differences in percentage of observations for each class of a qualitative variable. So in this case, we have types of car. So we have the sedan, we have the SUV, compact truck, and then hybrid. Of course, this is not the Indonesian setting. If this is the Indonesian setting, we're going to have a higher share for MPV, multi-purpose vehicle. We're also going to have a higher share of compact vehicle, and then we definitely have a very, very, very low share of sedan in the country. Okay, so while this graph or this pie chart looks bright, colorful, and then informative, but it's quite difficult to know what's the share of sedan in the market, what's the share of SUV in the market, what's the share of hybrid in the market. It's not easy to tell. So one thing that you can do to augment this particular pie chart to be better is to actually put in information of the share of each type. So for example, in the sedan, it's not relatively straightforward, but this is something like, say, 40%. So this is more straightforward to see between the eyes. The SUV is about 30%, and then the compact is about 15%, the truck is about 10%, and the hybrid is 5%. In this particular graph, they don't intend to show it because there is chosen to be even, 40, 30, 15, and so on. But in general cases, you could be facing with like 42.69% of MPV sold, and then 12.30% of compact cars sold. So it's not going to be straightforward. So in that case, you probably want to provide more information. Okay. Now the next thing is the frequency distribution. So frequency distribution is a grouping of quantitative data into mutually exclusive and collectively exhaustive classes showing the number of observations in each class. So you're going to decide the number of classes, the class interval, the individual class limits, and tally the data into classes and determine the number of the observations in each class. So again, you're going to decide on the number of classes, and we'll see how you actually going to decide the number of classes and determine the class interval. So how wide is one interval to be, and set the individual class limits, and then tally the data into these classes. Okay, so let's decide on the number of classes. So what we're going to do is we're going to use the 2 to the power of k larger than n rule, where n is 180 observations. So in this particular case, you want to choose k such that 2 to the power of k exceeds 180. Okay, so in this case, what you want to do is count 2 to the power of 6, 2 to the power of 7, 2 to the power of 8, and in such a way that 2 to the power of k is larger than 180. Now, we find that k is actually equal to 8. So 2 to the power of 8 is actually larger than 180. So in this particular case, we have 8 classes. Okay, now we know that we have 8 classes, so k is equal to 8. Then what we're going to do is we're going to determine the class interval. And so in this particular case, what we're going to do is take the maximum value in the data and take the minimum value in the data. Okay, and we calculate the difference between the maximum and the minimum and divide the difference with the number of classes. So in this case, the maximum value is 3,292, and then the lowest is 294. So if you look at the data, this is going to be the maximum profit, and this is going to be the smallest or the minimum profit. Calculating the difference and then dividing it by 8, you get 374. Again, you can do 374 out of the bat, or you want to do a little bit of rounding to say 375, but again, it doesn't really hurt to actually use 400 as the chosen interval. Again, this is not going to be a fixed formula in the sense that you have to use the number generated by this formula. No. You can actually be more flexible in that sense to create that classes. So in this particular case, we're going to use an interval of 400. Okay. Now, just to get yourself acquainted, the interval can also be referred to as the class width. Okay. All right. So, what's the smallest number? The smallest number is 294. Well, what you can do is that you can take the smaller number as the individual class limits. So since the lowest number is 294, then 294 is going to be included in a interval between 200 and 600. So again, the difference between 200 and 600 is going to be 400. Okay, and then the difference between 600 is going to be 400 as well. Now, just one thing that we need to be careful of is the we need to be collectively exhaustive, okay, and mutually exclusive. And in this case, what we're going to do is that the classes should be designed in such a way that it's both exhaustive and then mutually exclusive. Okay, so it means that you're not going to be able to put a value in two classes at the same time. Okay, in that case, it's not going to be mutually exclusive. Okay, you need to be able to put all values in one class. And if you find a case where you can put a particular profit observation into one of these 8 classes, then it means that it's not mutually exhaustive. So that's something for you to check when you're doing data analysis. Okay, then the next thing is probably the most clerical thing to do, and it's actually the more straightforward thing to do, is actually just tally the individual data into these classes and then determine the number of observations in each class. Well, it's straightforward. It's given by the calculations. Then what we're going to get is the frequency. Of course, what you can do is that in addition to the frequency, you can add another column to the right and then calculate the relative frequency. So you get the share of each class within the total observations that you get. It's another straightforward and simple thing that you need to do. But again, since you're using Microsoft Excel, since you're using more advanced statistical software such as SPSS or R, then counting frequency is not something that you're going to do. But again, just knowing the basic concepts and the way that they calculate it is going to be very helpful for you when you eventually take advantage of those technology and those software. Okay. Again, I mentioned that in addition to calculating the frequency, what you can do is actually calculate the relative frequency. This is quite straightforward, just by dividing the frequency with the total observations of 180. Quite straightforward, something that you can do swiftly. Okay, well, another thing that might be of interest to you is actually histogram. Now, in a lot of cases, histogram is actually very useful, but they're very underutilized. Not a lot of people actually use this histogram, but I personally love histogram. Histogram or an extension of histogram, such as, for example, the kernel density graph, is actually very intuitive. It tells you a lot about the way a variable is distributed, and it tells you a lot about the center of this distribution. And so this is something that you want to actually learn and then implement it in the future. So basically, this is a graph which the classes are marked on the horizontal axis, okay, and then the class frequencies on the vertical axis. Okay, so the class frequencies are represented by the heights of the bars. So for example, here there are 8 observations of profits between $200 and $600, and in this particular case there are 45 profit observations between 1800 and 2200. An example of histogram. Okay, another one is a frequency polygon. Well, this is actually straightforward as well. So what you can do is that the first thing that you need to do is you want to find the midpoint. Okay, well, for example, suppose that you have a profit of 200 and 600, so with a difference of 400. So the midpoint between 200 and 600 is going to be 400. So this could be another reason why you actually want to round you want to round the values. So for example, instead of an interval of 374 point something something, or instead of an interval of 375, what you want to have is actually an interval of 400. In this way, it's going to be more straightforward for you to find the midpoint. And so in this particular case, the midpoint is 400, and as you can remember, the interval is 400, so the next midpoint should be 400 plus 400, 800, and then the next one is supposed to be 800 plus 400, which is 1200. And if you go if you go on and on and on, then you get the midpoint for each interval. Okay. Now, for that midpoint, what you're going to do is identify what's the frequency, which is already available for you. So what you can do is that you can plot the midpoint on the horizontal axis, and then you can identify the frequency for each of the midpoint in the graph. So for example, here for a midpoint of 400, you have frequency of 8, and so on and so forth. So as you can imagine, the graph is going to get relatively smooth if you have more midpoints. Okay, the more midpoints you are, the smoother the graphic will be. But then, as the number of midpoint decreases, then the graph might not be as smooth as we have it in this slide. So again, it's really going to be useful when you're comparing two or more distributions. For example, you have two car dealers, or you have two locations of car dealers, and then you have profit observations of each car sold in each car dealer. And so in one car dealer, the distribution of profit is the following, but then in the other one, the distribution of profit is the following. This tells you a lot. So in this first car dealer, their profit doesn't vary that much, but the average is actually lower. However, for the second car dealer, the mean is higher, so it shifted to the right, but then the variance is quite high. So there are profits that are relatively high, and there are profits that is relatively low. So again, this is another intuition that you can actually gain using this frequency distribution or the frequency polygon. I think this is very useful. Okay. So another thing is the cumulative frequency distributions. So again, this is going to be a concept that we will revisit in the future. So basically, histogram and frequency polygon is going to provide you an illustration of a variable distribution or frequency distribution. And so the cumulative frequency distribution is going to provide you with an intuition or an insight about a cumulative distribution function. So that's something that we're going to look in several lectures, but it's useful for you guys to know right now. So to construct a cumulative frequency distribution, what we can do is that add each frequency to the frequencies before it. This shows how many values have accumulated as you move from one class down to the next class. So for example, you have observations between 200 or 600, or you can just say less than 600. And you have 8 observations. But then you have also observations from 600 into 1000. But then if you accumulate observations from 200 to 600, and then 600 to 1000, then you can say it's just observations of profits less than 1000. Okay, and since there are 11 profits between 600 and 1000, then what you can do is that you're going to add 8, which is the frequency in the previous profit class, and then add it to the 11, which is the number of profits in that particular class, and then the addition is going to be 19, which is going to be the cumulative frequency up to observation of profits less than 1000. And if you add it up, what you're going to do is you're going to get a cumulative frequency, and then the total should be the total number of observations that you have in your data. Okay, now again, as in the previous example, since you calculate frequency, and in this particular case you calculate cumulative frequency, you can always calculate cumulative relative frequency. How do you do that? Well, you just have to divide with the total number of observations, and in this case the total number of observations is 180. Okay, so if you do it right, then the last number in your cumulative relative frequency should be 100%. Okay, and so this is going to be a graphic of cumulative frequency polygon. Very straightforward. For example, for a profit between 200 and 600, then you get a particular number of cars sold. Okay, and another one is that here, if you see this graph, okay, it means that the number of cars sold for a profit below, say this is 1600, is 60 cars sold. Okay. Another thing is that the number of cars sold with profits less than 2000 is going to be about 50 something percent, or about 100 observations. So this is the way that you're going to interpret the cumulative frequency polygon. Okay, so this is the end of chapter 2, and I'll see you in the next lecture. Thank you.